Hello, this is Dr. Bob Brown. In this lesson, we're going to get into section 7.2 on right angle trigonometry. These are some of the things we're going to cover. We're going to define and then learn how to determine the values of trigonometric functions of acute angle. Now, I think we've already said that an acute angle is less than 90 degrees. So a right angle triangle is obviously going to have a right angle that's 90 degrees, and the other two angles are going to be acute angles that are less than 90 degrees. We also know that the sum of all the angles is 180 degrees. We're going to use fundamental identities, and if we're given the value of one of the trig functions, we're going to be able to find the values of the remaining trig functions. And then we're going to briefly talk about the complementary angle theorem. So to start off, finding the values of trigonometric functions of acute angles, we're going to first of all look at a right triangle, and we're going to define the sides. And I'm sure you've seen this before. For a right triangle, the two legs are going to be A and B. And of course, the hypotenuse is going to be labeled C. This angle here would be A. This angle here would be B. And this angle C is 90 degrees. And you should always remember that A plus B plus C is equal to 180 degrees. Now, looking at an acute angle here, let's now draw a right triangle. Label this angle theta, and the sides A and B. Notice that if you then create a new triangle having the same acute angle, that these triangles are similar triangles. And the interesting thing about this is that if you take the ratio of B over A, it's also going to equal the ratio of B prime over A prime. And similarly, B over C, since there are similar triangles, is going to equal B prime over C prime. Similarly, A over C will equal A prime over C prime. Now we're going to have some definitions. Given the right triangle and given the angle theta, side B is called the opposite side of angle theta. Side A is called the adjacent side angle theta. And you already know that the long side opposite the 90-degree angle is called the hypotenuse. So now here are the definitions of the trigonometric functions. And then we're going to talk about how to remember them or memorize them. The sine of theta is defined as the opposite side over the hypotenuse, which is b over c. The cosine is going to be adjacent over the hypotenuse, which is a over c. The tangent of theta is going to be defined as the opposite over the adjacent, which is b over a. Now, given these definitions, these three functions are all that we really need to know to solve right triangles, except we do define three other functions called the cosecant of theta, which is the hypotenuse over the opposite, which is simply c over b. And notice that cosecant of c then, cosecant of theta is equal to 1 over sine of theta. It's just the reciprocal of theta. Similarly, secant theta is equal to the hypotenuse over adjacent, which is c over a. And notice that secant theta is 1 over cosine of theta. And finally, the cotangent of theta is adjacent over opposite, which is a over b. And you'll notice that cotangent of theta is equal to 1 over tangent of theta. Now, there are various ways for you to remember how to write down the definitions of the three angles, of the three trig functions. And I would try to remember SOHCAHTOA. Write down SOHCAHTOA. And notice that looking at SOH, that tells you that the sine of theta is opposite over the hypotenuse. CA tells you that cosine is equal to the adjacent over the hypotenuse. And that tangent theta, TOA, is equal to opposite over the adjacent. So try to remember SOHCAHTOA. Another way that some folks have help remember how to write down SOHCAHTOA is to remember that it's some old hippie came a hopping through our apartment. That some old hippie came a hopping through our apartment. Now we're going to find the value of trigonometric functions given this particular triangle, which is a right triangle. We have the hypotenuse, that is 5, the adjacent angle is 3, and we're going to obviously use the Pythagorean theorem to find the opposite side, and then we can write down all the trig functions. So first of all, the hypotenuse is equal to 5, the adjacent is equal to 3, and so we know, using the Pythagorean theorem, that 3 squared plus 4 squared equal the hypotenuse squared. So it's 3 squared plus the opposite squared equal 5 squared. And solving for opposite squared, we get the opposite squared is 25 minus 9 equals 16. So the opposite is 4. So we now can label that the opposite is 4. And then we can simply write down the trig functions. The sine, which is opposite over hypotenuse, then would be 4 over 3. 4 over 5. The cosine of theta, which is the adjacent over the hypotenuse, would be 3 over 5, or 3/5. The tangent of theta is opposite over the adjacent, which is 4 over 3. And then the cosecant is 1 over the sine, which is just flipping over 4/5, so it would be 5/4. The secant is the hypotenuse over the adjacent, or 1 over the cosine, which is 5 over 3. And then finally, the cotangent is just the reciprocal of the tangent, which is taking the reciprocal of 4/3, which is 3/4. So now we have written down and calculated all the trig functions of the angle theta. Now we're going to look at using some fundamental identities. We've already said that, first of all, we've got the reciprocal identities. And remember that the cosecant of theta is 1 over the sine. The secant of theta is 1 over cosine. And the cotangent of theta is 1 over the tangent. Now, there are 2 other identities which we call the quotient identities, in which you can write the tangent of theta equals sine of theta over cosine of theta, and then of course the cotangent would just be the reciprocal of that, which would be cosine over sine. Now, just to illustrate that this is true, the tangent of theta is equal to b over a. But notice that b over c is equal to sine of theta, and a over c is equal to cosine of theta. Solving for b, cross multiplying, we get b is equal to c sine of theta. And solving for a, we get that a is equal to c cosine of theta. So plugging these in to tangent being b over a, we get c sine of theta over c cosine of theta. The c's cancel out, and we get and prove the identity that tangent of theta is sine theta over cosine theta. And then, of course, cosine would be, or cotangent would be cosine of theta over sine of theta. Okay, here's an example. Find the values of the remaining trig functions given that sine of theta and cosine of theta are, first of all, sine of theta is the square root of 5 over 5, and cosine of theta is 2 square roots of 5 over 5. Find the value of the 4 remaining trig functions. So, given that tangent of theta was sine theta over cosine theta, we just take the reciprocal, or take the ratio of sine of theta over cosine theta, which were given on the previous slide, and that is the square root of 5 over 5 divided by 2 square roots of 5 over 5, which is square root of 5 over 5 times 5 divided by the square root of 5. That's 2 square roots of 5. And then we get 1/2. Cosecant of theta is 1 over the sine of theta. So that's 1 over the sine of theta, which we were given, which is the square root of 5 over 5. And that is equal to 5 over the square root of 5, which, if you simplify it, becomes 5 square roots of 5 times e equals the square root of 5. Now the sine of theta is 1 over cosine theta, which is 1 over 2 square roots of 5 over 5. Flipping it over, we get 5 times 2 square roots of 5. And simplifying this, we get the square root of 5 over 2. Cotangent is 1 over the tangent of theta, which is 1 over 1/2, which is 2. So there we've calculated all the trig functions of the angle theta. Now, I'm going to use these figures to derive some new trig identities. One of the things you need to obviously always remember is that a squared plus b squared equals c squared, which is the Pythagorean theorem. Notice that sine of theta is equal to b over c. Cosine of theta is equal to a over c. So that means b is equal to c sine of theta, and a is equal to c cosine of theta. Plugging a and b into the Pythagorean theorem, we get a squared is equal to c squared cosine squared of theta. B squared is c squared sine squared of theta, and that equals c squared. And notice if we divide both sides through by c squared, we get, doing the sine square first, we get sine square theta plus cosine square theta is equal to 1. So this is an identity called one of the Pythagorean identities, in which the sum of sine squared and cosine squared is equal to 1. Now, taking the same figure and knowing that sine square theta plus cosine square theta equals 1, we can derive another identity. I'm going to divide each of these terms by cosine square theta. And since sine over cosine is tangent, this is tan square theta. This is 1. And 1 over cosine is equal to secant. So this would be secant squared of theta. And to get the other one we're going to show on the next page, if you take sine square theta plus cosine square theta equal 1 and divide through by sine square theta, we get 1 plus cotangent square theta is equal to cosecant square theta. So now, on this sheet, we have the three Pythagorean identities: sine squared plus cosine squared equal 1, tangent square theta plus 1 equal secant square theta, cotangent square theta plus 1 equals cosecant theta. So now here we have what we call the fundamental identities, which is sort of a summary here. The tangent is equal to sine over the cosine. The cotangent is cosine over the sine. Reciprocal identities: cosecant is 1 over the sine, secant is 1 over the cosine, and cotangent is 1 over the tangent. And then the Pythagorean identities that we just derived. Now, here it's asking us to find the exact values of each expression, not using a calculator. This is going to be very, very simple. It's worked on the next page, but although we could easily work it here, in fact, let's go ahead and work it here. We know that sine over cosine is equal to tangent. So this is going to be tangent of 20 degrees. So tangent of 20 minus tangent of 20 is equal to 0, so that'll be the answer. We know that 1 over secant squared of theta happens to be cosine squared of theta, because secant of theta is 1 over cosine of theta. So 1 over secant squared of theta then would be cosine squared of theta, And so we have sine square of pi over 12 plus cosine squared of pi over 12, and we know that equals 1. So looking at the next page, we get exactly what we were talking about. Tangent of 20 minus sine of 20 over cosine 20 degrees is tangent of 20 degrees minus tangent of 20 degrees is 0. And then sine square of pi over 12 plus 1 over secant squared of pi over 12. 1 over secant squared of pi over 12 is cosine squared of pi over 12. And we know that sine squared plus cosine squared is equal to 1. Very simple. Now, here we're going to talk about finding the values of the remaining trig functions given the value of one of them. We're given that sine of theta is 1/3 and that theta is an acute angle. Let's find the exact value of each of the remaining 5 trigonometric functions. Well, the first thing you should do here is know that sine of theta is equal to the opposite over the hypotenuse, and draw a triangle. If that is opposite over the hypotenuse, you can just put 1 and 3. And this satisfies the information you're given that sine of theta is 1/3. And now you can use the Pythagorean theorem to find the adjacent. And this is illustrated on the next page. We draw the triangle as we just talked about, with the opposite equal to 1, hypotenuse equal to 3, and then write down the Pythagorean theorem, a squared plus b squared equal c squared, and we get a squared plus 1 squared equals 3 squared, which is 9. A squared is equal to 8, and 8, of course, is 4 times 2, so the square root of that is 2 times the square root of 2. So A is 2 square roots of 2. So now we've got the triangle identified, and the cosine would be adjacent over hypotenuse, which is 2 square roots of 2 divided by 3. So now we have cosine. The tangent is equal to opposite over adjacent, which would be 1 divided by A, which is 2 square roots of 2. Taking the reciprocal of 2 square roots of 2, we get that simplifies to the square root of 2 divided by 4. And finally, cosecant of theta would be the hypotenuse over the opposite, which would be 3 over 1 equals 3. And the secant theta would be hypotenuse over the adjacent, which is 3 divided by 2 square roots of 2. And then finally, the cotangent would be A over B, or the adjacent, which is 2 square roots of 2, divided by B, which is 1. So the cotangent is 2 square roots of 2. Now notice there's another way to do this using the identities. You could use sine squared plus cosine squared is equal to 1, and then plug in the fact that sine of theta is 1/3, so sine squared would be 1/9, leaving a plus cosine squared theta is equal to 1. And cosine squared theta then would be 1 minus 1/9 equal 8/9. And taking the square root, you get 2 square roots of 2 over 3. So now we've got sine of theta is 1/3. We got cosine of theta is 2 square roots of 2 over 3. So now we can use the fact that tangent is equal to sine over the cosine, which is 1/3 divided by 2 square roots of 2 over 3. Simplifying the radical, we get the square root of 2 over 4. The cotangent is 1 over tangent, which would be the reciprocal of the square root of 2 over 4. Flipping it over, we get the final answer of 2 square roots of 2. And then finally, the secant is 1 over the cosine. The cosine is 2 square roots of 2 over 3. Simplifying that, we get 3 square roots of 2 over 4. Cosecant, 1 over sine, is just 1 over 1/3, which is 3. So this is just a summary of how you go about doing it. You draw a right triangle, assign 2 of the sides based on the value of the given trig functions, find the length of the third side, and then use the definitions of the trig functions to do the calculation. Or, if you want to, you can use the identities. I would generally do the drawing myself. Let's just do one other one, and we'll do just a little bit of this one. Here we're given the tangent of theta is 1/2. So because the tangent is opposite over the adjacent, we can write that the adjacent then is 1, and the opposite is 1, and the adjacent is 2. Now writing c squared is equal to 2 squared plus 1 squared, we get that c squared is equal to 5, and c equals the square root of 5. So let's just do a couple of these. Sine of theta would be opposite over the hypotenuse equals 1 divided by c, which is the square root of 5, which equals the square root of 5 over 5. And the cosine of theta would be adjacent over the hypotenuse, which is 2 divided by the square root of 5, equals 2 square roots of 5 over 5. And I'll just leave it to you to write down the cotangent and the cosecant and the secant. Now, since this is the age of calculators, this particular theorem is not necessarily used all that much, but it's called the complementary angle theorem. Notice in a right triangle that has sides A, B, and C, and angles A, B, and angle C, that A plus B has to equal 90 degrees. That's because the total of the sum of the angles in a triangle is 180, and if the C is a right angle, which is 90, then A and B add up to 90 degrees, and A and B are complementary. So those are complementary angles. And notice the sine of B equals B over C. But the cosine of A, looking at it this way, is also equal to B over C. So, if A and B are complementary, the sine of B is equal to cosine of A. The cosine of B is equal to sine of A. Doing the same thing with the tangent and cotangent, you get that the tangent of B is equal to cotangent of A. The cosecant of B is equal to secant of A. Secant of B is equal to the cosecant of A. And the cotangent of B is equal to the tangent of A. And this leads to this theorem they call the complementary angle theorem. It says the cofunctions of complementary angles are equal. And here's a summary here. By the way, this is writing it in degrees and writing it in radians. The sine of 62 degrees is going to be the cosine of 90 minus 62, which is cosine of 28. The tangent of pi over 12 is going to be the cotangent of 90, which is pi over 2 minus pi over 12, which is cotangent of 5 pi over 12. The cosine of pi over 4 is going to be the sine of 90 degrees, which is pi over 2, minus pi over 4, which is sine of pi over 4. Finally, cosecant of pi over 6 is secant of 90 degrees, which is pi over 2, minus pi over 6. pi over 2 minus pi over 6 is pi over 3. And so we have just an example of using the complementary angle theorem. And that is the lecture for today.